So in our last video, we talked briefly, at least we introduced the concept of rational exponents, so converting between an nth root and a rational exponent. But I wanted to go a little more into that and do some examples on actually utilizing these and why these can actually be pretty helpful. So let's start with this first example. Here we have 64 to the 1/3. If we remember correctly, this is the same thing as finding the cube root of 64. Okay, so the cube root of 64. And the cube root of 64 is just 4. Okay, so we know the cube root of 64 is 4, so we're good there. And then similarly, here we have 81 to the 1/4. This is just the same thing as finding the 4th root of 81. And the 4th root of 81 is just 3, since 3 to the 4th is equal to 3 times 3 times 3, which is just 81, right? So those aren't too bad. We saw examples like that in the previous one. But where things get a little bit more fun is when we don't have a some number raised to the 1 over something. What happens when we have like the similar situation here, 81, and we're raising it to the 3/4? What happens there? Okay, well, this is admittedly kind of interesting, right? So we can kind of think of this as, not kind of, you can definitely think of this as 81 to the 1/4 raised to the 3rd power. Okay, that works. Or if it's more convenient, you can think of this as 81 to the 3rd raised to the 1/4. Okay, and whichever of those sounds more convenient to you is the one that I would go with. Okay, so these two are the same, and the reason they're the same is because if you remember, if we have a to the b raised to the c, this is equal to a to the b times c, and we know that b times c is equal to c times b. So we can actually just switch the order here. We can have 81 to the 1/4 to the 3rd, or 81 to the 3rd to the 1/4. They are both equal to each other, okay? This is all just a direct consequence of the basic rules of multiplication. Okay, so what I would do is I would write out your problem like that, like how we just did. We can write it as 81 to the 1/4 times 3, or 81 to the 3rd times 1/4, and you figure out which one sounds easier. I don't know about you, but I don't want to take 81 to the 3rd, which is going to be a very large number. 81 to the 3rd is 531,441. I don't want to try and deal with trying to find the 4th root of that. I would much rather take the 4th root of 81 and take that to the 3rd, right? Because we know that the 4th root of 81 is 3. So let's go ahead with this one, right? So we know that the 81 to the 1/4, that is just 3. And so then we can take 3 to the 3rd. Okay? And we know that 3 to the 3rd is just going to be 27. Now, if you wanted to, you can, let's just on a calculator, you could go through 81 to the 3rd and then take that to the 1/4 if you want, and that's fine. You would definitely get 27, but I think that this one is definitely easier. Oftentimes, you're going to find raising the number on the inside to the fractional power first is an easier way to do it, right? So, but not always. You don't always get a nice clean number when you do that. So sometimes it's easier to do it the other way. Okay, let's look at 4 to the 5/2. So we can write this as 4 to the 1/2 raised to the 5th, or we can write this as 4 to the 5th raised to the 1/2. Okay, so if we take 4 to the 5th, that's going to give us 1,024. That might not be terrible to find the square root of, but I think it would be easier to find the square root of 4 and take that to the 5th, right? So we know right away that 4 to the 1/2, or the square root of 4, is just going to be 2. And then we'll take that to the 5th. And 2 to the 5th, we know that. 2 to the 5th is just going to be 32. Okay, so we know that this is equal to 32. So 4 to the 5/2 is equal to 32. Okay, well, this is a little more interesting. How about 9 to the negative 3 over 2? What happens here? Okay, well, it is true that you can write that you can break it up right away. That's totally fine. But anytime I see a negative exponent, I like to go ahead and deal with the negative aspect of it right away and just get it out of the way. Okay. So remember, if you have a to the negative b, this is equal to 1 over a to the b. Okay. Or more generally, if you have a over c to the negative b, this is equal to c over a to the b. Okay, so essentially what you're doing is you're flipping the fraction, right? Or if you just have a whole number, you're doing 1 over that number and you're raising it to the exponent. So here we have 9 to the negative 3 over 2. This is the same thing as 1 over 9 to the 3 over 2. Okay. Okay. So, let's go ahead with that then, right? We'll start with writing this out. So we can write this as 1 over 9 raised to the third, and we can take the 1/2 of that. Or we can think of this as 1 over 9 to the 1/2 raised to the third. Okay, and I think that's probably the one we're going to go with here. Okay, so if we have 1 over 9 to the 1/2, we're taking the square root of 1/9. Or we're taking the square root of 1 over, sorry, we're taking 1 over the square root of 9, because the square root of 1 is just 1. The nth root of anything of 1 is just 1, so we can just focus on the denominator. So if we have the square root, we're just going to move all of these down a little bit. Okay, so if we have this, so this will be the same thing as 1 over 9 to the 1/2 raised to the third. And the square root of 9 is just 3, so this becomes 1 over 3 to the third. Okay, and this is the same thing as 1 over 3 to the third. And again, that's because we can think of this as 1 to the third, but 1 to the third is just 1. So it becomes 1 over 3 to the third. And 3 to the third is going to give us 27. So we're going to have 1 over 27. Okay, how about 1 over 32 to the negative 2 over 5? Well, let's go ahead and flip this then. Right away, let's deal with that negative sign. So what we're going to do is we're just going to flip the fraction and keep the exponent. So this is going to become 32 over 1 to the 2 over 5. Or we can just write this as 32 to the 2 over 5. Okay, so we can rewrite this as, this is 32 squared to the 1/5. Or you can rewrite this as 32, the 5th root, the 1/5 of 32 raised to the 2, or square to that, right? Again, I'm kind of thinking that's the way to go, because we know that the 5th root of 32 is going to be 2. So this is going to become 2 squared, which is just 4. So that was not too bad. Okay, how about 1/4 to the negative 3 over 2? Okay, well, once again, we're going to deal with that negative sign. Let's flip this. So this is going to become 4 to the 3 over 2. And we can rewrite this as, 4 to the third raised to the 1/2. Or we can write this as 4 to the 1/2 raised to the third. And I like that second one a little better. So that's going to become 2 to the third, which is just 8. Okay, let's do one more. Here we have 16 to the negative 3 over 4. This is, again, if we deal with that negative sign first, we're going to get 1 over 16 raised to the 3 over 4. Okay, so we can rewrite this now. If we distribute that exponent, we can go ahead and rewrite this as 1 over 16 to the third. Take the fourth root of that, or we can rewrite this as 1 over 16, the fourth root of that, and cube it. And that's probably what we're going to do. So the fourth root of 16 is just going to be 2, since 2 to the fourth is just 2. Or 2 to the fourth is just 16. So we're going to have 1/2 cubed, and 1/2 times 1/2 times 1/2 is just 1 over 8.